Okay, let's see. What are we doing to? So if I look at the syllabus, then that gives me the opportunity to kind of move forward, and I'm going to go ahead and start attacking ADONET and using databases. The faster I get through the material here, or the sooner I get through this material, the more you'll have, the time at the end of the semester to just work on getting that assignment, the last assignment, and the program 7 done. So let's take a look at that material. Let me just make sure. Can everyone hear me okay? Yes, this is being recorded. Thanks, Allie. And
Yeah.
yeah, anytime you all can remind me to make sure I'm recording, that would be very helpful. Let's see, ADONET.
Was that me?
No, that's somebody else. I just muted them. If you had a question, you're coming in broken, see if you can get your microphone, and see if there's a problem. There's a lot of static with that one. Okay, so ADONET. That's one of the .NET's underlying databases. There's a couple ways we teach you during the course of your time here at CNM on how to work with databases in with Microsoft stuff. One is with ADONET, which is basically making commands with SQL and sending them to a SQL database and getting them back. And then we later on in CIS1280202004, I will teach you how to use Entity Framework, which uses an object relational model to do that. And so that kind of gives you, the idea is to give you two different ways of working with data in the .NET world. Most of the time, you're probably using some kind of object relational model that really abstracts away how you're working with your data if you're doing .NET stuff. But it's useful to start off by understanding how to work with at the lower level and connect to data, more fundamentally. So if you're used to using some entity framework or anything like that, we get to that later on. But for this course, I want to use ADONET. And so the things that we have to learn how to do is how to make a database connection, how to create database commands, how to execute them, and then use this thing called a data reader to read data. We may also, since we're getting to this pretty early, we might also go over how a data adapter works. So, ADONET stands for ActiveX Data Objects, so it's been around for a while. And it's basically a library of components that are used to work with databases. And you're going to find that in the programming world, there are a couple seams between how things work. You've been, so far we've been having you work, it's just, regular software programming type of stuff. But now what we are doing is we're going to be interfacing code with databases. And the way databases are designed is just slightly different than the way we do things in programming. In programming, we do things kind of using an object-oriented approach, which means we define classes and create objects. Databases, however, are the primary model until more recently has been this relational model where you define tables and you relate the tables through an ID field. And the two models are very similar, but there's slight enough differences that this causes thrash in frameworks almost constantly. So you're going to see that there's this continuous development of new ways to connect your databases to your programs, and then people find that there's a little problem because the databases kind of work a little differently, and database developers think a little differently than programmers. And so you're always going to find that there's a little bit of weirdnesses and complexities and hackiness in this area. That's okay. That's called job security. So we just have to become comfortable with learning new things on a continuous basis. So the other thing with .NET, one of the things that they needed to do is be able to hook or connect up our software with a lot of different types of databases. So you have SQL Server out there, you have Oracle, and you have this open database connectivity model that can be used to hook up to a lot of different types of databases. OLADB, which I don't know if it's being used so much anymore, and there's a whole bunch of new database approaches that are out there. So, between Oracle, and as you can imagine, Oracle and Microsoft work very closely together to make sure that there's a lot of connectivity between those systems. Anyone believe me? Okay, no, they don't. So there's slight differences. And on top of that, you have, programmers are running there like a bunch of kids throwing all kinds of new frameworks and stuff out there. So, and new database approaches, which are often good because they're very creative. But now we have the problem of, okay, in our program, we want to connect to these things, and we don't have to want to rewrite our code every single time that something new comes out. So what they do is they create a layer between your code and the different types of database connectivities by providing these different data providers. And that means that often you can write your code one way, and then by just switching out which data provider you're using, you can connect to any different types of databases without having to do a lot of change in your code. So that's one good thing that Microsoft has done with .NET. The namespaces that we end up using are system.data, and you'll see that provider base is a base class for data providers, and then you can see here we have several provider classes like ODBC, OLADB, SQL, and so on and so forth. And so all of as we've learned, we can imagine this is an abstract class, and all those implement that abstract class so that then whenever we're working with data, we can have one set of functions to call, and we know that they will work with any number of database systems. And those providers will provide us with these kinds of objects that we can work with. A data set, a data table, a data row, data column, and those are pretty much what you would imagine. A data table is a representation as an object of a table of data. You probably can imagine it's a bit like a list. And a table has multiple rows. It also has multiple columns. And the columns define what kind of fields are in this table, and the rows are the actual data that are in that row. And then there's some other things that are in there. They can represent the constraints in a SQL database with the constraints class, and you can create representations of foreign key behaviors with data relations. So you can actually make an object model of whatever's in the database with all these classes. And then there are these other classes that represent things like SQL commands and SQL connections. So there's the command, there's connections, there's a data adapter, which allows us to actually kind of automate a lot of the process of keeping track of what needs to be changed and then making those changes be updated in the database. These other things are kind of more direct. You make a command and then you execute the command, and it'll send it to your SQL command to the database. We will talk about SQL injection and how to prevent that. Very good question. I think Carrie's talked about that before. There are wrong ways to build your SQL queries, and there are correct ways which will sanitize your inputs. And pretty much today, every single database or programming language will have specific ways to sanitize your input. So anytime you're learning a new language and you're connecting to data, one of the things you want to do is type in SQL injection, the language, and whatever data provider you're providing, and research how do they sanitize inputs. We'll talk about that in a bit. And then so you have all these classes that we're gonna see some of these and how we use them. So the first thing we need to be able to do is connect to our database, and we do that with the database connection. And we can actually create a database in a project. When you add new item, there's an option under data to add different kinds of databases. You could even use XML files as data sources, for example. The one we're going to use is the service-based database. Yes, thanks, Carrie. The service-based database will be a SQL Server database. And within Visual Studio, it actually provides you the ability to manage your databases directly. You can also create your databases outside of it using SQL Server Management Studio, but you have that stuff in Visual Studio. And when you do that, you have the ability to look at your databases in your project. There's a server explorer where you can find your database, and you can actually explore what tables there are. And one of the things that happens, it depends on the type of project you're working on, but there's two ways that these databases get used. If it's a Windows type of application or something, what happens is you have a database in your project and each time you compile, a copy of that database is put into the debug folder. And then when you run the program, you're actually working with that copy of the database. When you recompile, it actually recopies the database and obliterates what was there. When you're working with databases, the way you want to think about it is, as a programmer, typically you are not working with the live data, which would be considered a very dangerous and unrecommended way of developing your application. You're working with a development database, and that development database really is the thing that will be delivered when your project is deployed. So sometimes you actually may not even deploy with a database, and you'll actually and the code will actually create your database for you. Other times you will create a starting database, but the only things that you will have in it will be just whatever would be in there when the application first runs. So there's kind of a distinction between the database you have in your project folder and the one that ends up in the bin folder, in the debug folder when you compile. So to connect our database, we need something called a connection string. And what a connection string is it's a string, it's a piece of text that has all the information needed for a program to connect up to that database. And then once you have that connection string, you need a function that actually does the connection. These are also inherited these are in an inherited structure based on the kind of database you're connecting to, because there's different ways to connect up to that database. So there's the base DB connection class, and then you have actual implementations of that based on each database: a SQL connection, OLADB connection, ODBC connection. And so you'll instantiate the type of connection object that you need, and then connect to that database. We'll be using SQL connection. So this is what the code looks like. So here I have a connection string. It says, it's going to be a local server, using integrated security, and the database name is Northwind. And then what we do is we create a SQL connection, and we pass in the string for that connection, the connection string to the SQL connection, and then we call the open method on the connection, and that opens up the connection. Then we do something, and then we close the connection. So, and then we'll use SQL Data Client. We create the connection string, we initiate it, we open it, and then we close it. So that's the basic process. We're going to find that there's a lot of things we're going to do because we don't want to hard code this string inside of our code typically. So we're going to actually put that in a configuration file. And then there's things we want to do to make sure that the database gets closed. So we're actually going to run this in something called the using directive in order to make sure our connection is always closed. Like files, you want your databases to be opened, do your work, and close them as fast as possible. Why is that?
Because you can't have multiple connections open at once. It does not like that.
Actually, I think databases, you can have a few number of connections, but they're limited. And
don't do it.
Yeah. So
or if you're doing something in transactions, it just causes all kinds of
So and it's a resource, and so the shorter you use that resource, the more it's available. Otherwise, you can also set up big database farms that take the next query and run them, and they're all connected and everything. But it does use up resources when you do that. So, and also databases are expensive. If you've ever get your own service provider, you always have to pay for usually they only give you a limited number of databases. Connection string format is basically it's a string, and there's a website out there that talks about how connection strings are built. Most of the time, though, you can get that from the database. So when you create your database, the application you're making your database in will actually give you the ability to grab the connection string from it. So you often don't have to write it from scratch, or the application, if you're using NAD framework, it will kind of automatically do a lot of that stuff for you. One of the things in the connect, so in this one, you have to specify which server you're using, and then integrated security. It's a good idea if you can to use integrated security because it uses Windows authentication, and it keeps your username and password out of your source code. Why would it be a bad idea to put your username and password in the source code?
Yeah, because anybody who can get access to your code base can have access to it. And if they happen to leave the company, hey, they have all the logins.
Yeah, and if you were to put your code up to GitHub and happen to be on the public side, that'd probably be a bad thing. So yeah, usually we want to try to keep those out of there. Sometimes they don't make it easy for us if they're not letting you use Windows authentication on whatever service provider you have, or there are other tricks you can do, but if you basically want to keep your logins out of there, Windows authentication does, setting it to SSPI kind of prevents that from happening. All right, and then your database, you got to put the name of your database so that you know which database you're connected to on that server. And there's this website called connectionstrings.com. You can go to there, and let's see if it's still alive. Sometimes I put these links in from a long time ago. Yeah, and they've got a reference here on connection strings, so you can read about it. And so, would it be a good idea to litter your code with the connection string that you're using all throughout your code, so it's in like 50 different places?
Nope, you just want to put it in like in the app settings or something.
Yeah. And, you know, generally, this is the same thing that's true about any kind of magic number or magic value, right? We don't like, it's better to have like something stored as maybe a, we've probably seen how to use constants or, you know, in C++, you know, define statements to prevent that. You know, today we're going to learn how to use or we can make a configuration file that will store those kinds of things. We're going to see how to use this with connection strings, but you can actually use the same process for anything that, you know, is like, hey, this is some kind of value that could change later on, or, you know, and I use it throughout the program. We can use a configuration file to store that thing, and then that way we always reference to that configuration file. So that's going to be another thing we're going to learn when we do this. So this is an example of an XML configuration file. We'll see if they've moved this to JSON in whatever version that we're working in right now. It's not much different, but basically, you know, in XML you would have configuration would be top level, and then somewhere within configuration you'd create connection strings, and you say add, and then you provide the attributes you want for that connection string. So name, provider name, and connection string. The name is basically the key value that you're going to search for this connection string with. And then the provider name is actually which class you're going to use to access this. So under the system data namespace, there's several providers. You can specify the provider here, which is kind of cool because if you want to use a different database, you switch the provider, update the connection string, and it should just work. Notice the judicious word of the word should. It'll work, I'm pretty sure. Anyway, let's see. So we're going to be using something called a configuration manager class to get access to that connection file. And so here they've made a little function to grab the information from the connection string. I'm not sure we're going to be necessarily using that, but the way you get access to it is there's this class called configuration manager, and there's an object in there called connection strings, which you notice is, if I look at this, is connection strings a static or instance property? And the hint is the color this is. It's static. So basically, if you bring in the configuration namespace by using system configuration, you get access to the configuration manager class, and that configuration manager class basically gives access to this file.
Core 3.1 has some fun stupid with that. Just be forewarned.
Right on. And then yeah, because they probably switched to JSON, and then they have some different.
No,
they want to do the injection stuff.
You have to add new dependencies to it because they don't, and it breaks a bunch of stuff if you were working in Core 2.0. So
we'll find out.
I think it's Microsoft.extensions.configuration, and if you're using JSON, you have to use Microsoft.extensions.configurations.json.
Yeah.
That took me about 6 hours this week.
Right on. So you're working on 3.1 projects now?
Yeah, we're upgrading our old projects too. So we're learning all kinds of stupid things.
They're not stupid. They're things that are making the architecture much better. Okay. Anyway.
Sure, we'll go with that.
Just giving some Microsoft Kool-Aid there. Anyway, so here we have some, the connection strings, and basically you'll have a class that you can pull that out of. And you'll notice that there's a square brace and a name. Notice that the name is a string. So this isn't an ID field. It's not an int. So what do you suppose connection strings is? Can anyone kind of guess what kind of class that is? Not really a list, because a list would use an index number, but this is using a string, a key field. Yeah, this is a dictionary. And so what you're using, So this name right here, that's the key field that will be used here to figure out which connection string it's going to pull out of there. Now, we're probably only going to have one connection string in our system. It is entirely possible for an application to have multiple databases it's connecting to. But we're just going to use one. And so we'll put the name of our connection, and that will get the connection string settings. And then from settings, there's each connection string has all these attributes, provider name. And notice that inside of this connection string, you have an attribute connection string. So down here, we get settings.connection string, which is where we're going to get our connection. So we'll see that when we do our demo in a little bit more detail. So databases can only have a limited number of connections open at one time. It's therefore important to keep those connections open and closed the minimum of time possible. So, often in a lot of languages, we do that with a try and finally. And so if you're doing that, it would actually be, it's not unusual to put opening your connections and doing all your data stuff in a try block. Why would this be a good candidate to do exception handling with?
Because a lot of things can happen when you're dealing with a database.
Yep. What if the database goes down? What if the database has too many instances open at that one time, and you need to delay and wait? So you could do a lot of stuff here.
Plus, in your patches, you can roll back transactions or whatever needs to happen, because you may only have a partial insert. There's all kinds of stupid stuff you can do with it.
So often you're going to do your work with a try catch, and the exception you'll catch is the SQL exception, and decide how you want to respond to that exception here. And then often you put the close and a finally. Except that often while that would probably work, we tend to use a using directive instead. And with a using directive, what that does is inside the using directive, you can declare anything in here, and that curly brace is backwards, by the way. And within that block of code, that connection will exist. And as soon as you exit that block of code, as soon as you're out of scope of that block of code, whether it's because of an exception or you're just done with that block of code, this object here that's been declared in the using directive will then immediately, its destructor will be called and it will be closed. And the destructor for a SQL connection or any other kind of connection will close your connection. So you notice there's no close here, but it's placed in a using directive so we can be sure that this connection will be automatically closed. And so you might have a structure like this. Using SQL connection, open your connection, close your connection, do some stuff. You might put that all in the try-catch block and then catch the exceptions. So that could be, you could combine both methods. So I'm going to transfer over to the demo at this point, and then go back and forth with this. Oh, I think I was where I was supposed to be at. Let's see. So going to ADONET. It looks like I have a starter. Hopefully that will be fine. And then we have the instructions. Put that over here. So extract that and open up the starter. Do I trust me? Probably. Okay, so this is our database with school. I mean, this is our application with school.cs and student.cs. Probably a good idea for us to run this initially. Let's let it do its thing. Okay, so is it starting? Yeah, it's starting to build. Make sure it runs before, because this was done with the previous versions, so usually they should build okay though. Yay, build succeeded. And here we have, I think we did this as a demo before. We have our courses, we have our students, campuses. Button and label don't do anything right now. Oh, they make it go away. Okay, let me try that again. And let's see, what does students do? If I hit add student, yep, I get this window. Huh, looks like we got some kind of error. We might have to fix that. Let me run in debug mode, see where I'm having a problem. Oh, it's because I put in more than 100. I got it. So we put in a bug fix. If it goes over 100, should not close the entire application. Who coded this? That type of thing. And yeah, that looks like that's working. So, so it looks like our application is working pretty well. Okay, did that work for everybody? So it would make sense that, you know, this application right now, does it preserve anything after we stop running the program? What happens to that list of students? Yeah, because right now it's just all going to RAM. So why would we want a database? Primarily to preserve information from one run to the next. In other words, to persist the information. So we're going to add a database. And the way we do that is we right-click on our project, not the solution, but the project, and then you click Add. And we're going to add a new item, just like we add everything else. And then we're going to select Data, and we're going to select Service-Based Database. And what do they want us to call this thing? Probably something like SchoolDB. Is that what it was? Yeah, SchoolDB. At least that's what I'm going to call mine. So give it a name. Probably adding DB to it is not a bad idea. So that when you're looking at that file, you know it's a database. Note that the file extension will be, I think it was MDF. And once you add that, you should see that show up. And we'll give it a second. Yeah, MDF. And so now you have your school database in there, in the project. Everyone with me?
Yep.
So remember it's service-based database. So then to find your database, just double click on it and it should open it up over here in the Server Explorer. I'm going to pin that open because I'm going to be working with that quite a bit. And you'll see that you have data connections and your database. If you have multiple databases, they will kind of all show up here in the Server Explorer. And you can expand these folders and see what's in here. There really isn't much right now because it's brand new. We didn't create any stored procedures. Some of you have, make sure you double click on the school. It should be schooldb.mdf and then double click on it and it should open up the Server Explorer. Okay, then go to Project, right click on the project, add new item, service-based database, and then in here, make it SchoolDB. Okay. Yeah. So I've been working with databases for a bit of this app with this installation, so it's probably already in there. If it's taking a little while to load, sometimes I may have to bring some stuff in. So I'll give people a chance to kind of get caught up here because I want to make sure that we're all kind of in sync at this point. So I'm going to put on a let's see how to do that. And so if you could, when you all are ready to continue on, click on that poll that should have just opened up. Hopefully it's displaying. Anyone need an explanation of how to get that all sorted out? Cool. Yeah, and usually databases are another one of those where it either works great or it goes terribly wrong. Lately, though, it's been usually working pretty good. I think Microsoft smoothed out a lot of things in the way databases work. It may have just been the school. Sometimes the installation there, they will shut down SQL Server and you have to start up the process. I may talk about later how you do that if it seems like it can't connect up to the database. But it's been working pretty good to date. So it looks like I got 3 more people. If you need some help figuring out how to make it work, I can review the step.
I'm good. Don't wait on me.
Okay. Okay, so I'm going to. It looks like most people have it. If you need to be caught up during the break, I'll help you get caught up. But basically, now you have your school DB here, and next thing we want to do is we want to add a table. Really, you can think of a database as a collection of tables, and a table is a collection of rows. And what we're going to do is School.cs has majors, courses, and campuses. We're going to put those inside of the database rather than hard coding them in our code. And so the way we're going to do that is we're going to right-click on our tables and add new table. And if you've worked with Oracle and you as a designer, the layout's going to be a little different, but pretty much there's not 500 different ways of setting up working with a database. They're going to have a lot of the same things. Down here, you have use SQL. You can either write your code here or use the designer. This is Microsoft, so a lot of times they give you a designer to work with, and I kind of work back and forth when I'm using this thing because some things are just easier using the designer. But if you're really comfortable with your SQL, you can just start typing down here and it'll be reflected up there. So,
and this is Oracle based?
No, this is Microsoft SQL based.
Okay, so SQL Server based. Yeah. The syntax is different.
Slightly.
Be aware of that. It's enough that you may want to Google.
Let's see, what do we want? So we're going to store information for majors. And I guess what we need is we need an ID field and a title. So not very much to store in this one. And so you can see you type title up here and it writes your create table code down here. The ID field. So this says this changes to major ID. I've actually started just leaving things as just ID for my ID fields. There's probably different preferences and philosophies on how you want to do that. You have the option to choose to allow nulls or not allow nulls. We're going to leave title as nullable. And
do yourself a big favor and don't name everything in the major table major title, major whatever. It's going to be bad.
Yes. Because then you have the major thing going on. And then
it becomes harder to query a table because a lot of your databases will actually help you autocomplete tab completion. Yeah, when you put major on front of everything, good luck finding a field.
And like if you start using like if you use object relational modelers, they will have kind of some preconceived ideas of how things will be done. If you follow those as much as possible, you'll make your life a lot easier. So you need to understand the framework you're working with. So if we look at major ID, the other thing that we can do is, let's see, is it in the properties? You can actually set some of these things with properties too. Notice I selected properties over here, and when I select these, it changes. We're going to go to the ID field here, and we're going to go to the identity specification property. Does everyone see that? And there's this one thing that says is identity, and it's currently false. I want my ID fields to be identity, so I'm going to set them to true. And you can see the difference. If you just say primary key, it's a primary key. You can identify things. If you set identity, primary key and identity, what does identity do in SQL?
It auto increments so that you don't have to set it every time you insert something into it.
Yeah, so you want your ID fields to auto increment if you can, unless there's a good reason not to. And you can see here, you can actually set the behavior where what the seed is. And right now we're using the default behavior. And this is an example of where there's a difference between the way programmers think and the way database people think. What number do database people start off their collections with?
1.
One.
Because your headers are your 0 technically.
Yes. So they start off with 1, and we tend to start with 0. So a little difference. Just be aware of it. Leave it like that. Don't drive your database administrator crazy, and leave that as a 1. And then this will increment, 1 every time you add a new one. So you always want to have identity here. And you can change things like number of characters. This is an N chart 10. I'm going to pick, I don't know, what's good here?
For a title, probably 30 or 60.
Yeah, it looks like they got nvarchar.
You should be able to implement it yourself, just changing the number.
Yeah, you can change it there if you wanted. I'm just going to select the drop down for 50. So that's how we create a table. So now create the same kind of table for, oh, I don't want to save that. So after you create this, after you do this, then the next thing you want to do is click on update. And what will happen is, it looked kind of odd. It's like, did we actually change? We haven't actually created a table yet. What we've done is you've written the code to make a table. And now you can either generate script or update database. So you might generate script if you're just using this to write your create code and you're making a database project where you're just making a bunch of code. But we're just going to update database and actually make it apply it to this database.
You probably have to refresh.
I'm going to give it a second because I expect it to be able to do this thing its own. Yeah, I had to refresh. One thing I didn't do, though, that was a mistake is I forgot to rename my table. So I'm going to change this to, should I call it major or majors?
That sounds like a business person decision. That's when you go to the business owner and say,
Yeah, most database people actually prefer to make their tables singular. As programmers, we like to make our collection classes plural, another difference. So I'm going to use the database convention. And so if I change the name, watch what happens. I'm going to click update and update database and then refresh this. Notice that I still have that other table sitting there. So I'm going to delete that one. So if you create that table and you rename your table like this, you have to delete that one. And notice that the delete is actually a script action. So then you click update database, and now I've got my table the way I want it. Does that make sense?
Mm-hmm.
So now do the same thing for campus and course. You type that in here and then do the update. And then afterwards, click on the refresh and it should show up. And then I'll make another table, add new table. This one will be let's see, campus. We're going to do campus and course next. So you can either use the properties and use all the other features and type it up here, or you can just type things in directly. In fact, if I copy this, the next one will be the same, I think.
Wouldn't it be good to have like a location and all kinds of good stuff in this?
Well, yeah, you could do all that, but we're just doing the simple. We're just doing the simple part first.
Yep, primary key.
Ah. Okay, so does everyone have their three? I'll do another poll.
Yep. Why can't I? Key.
let me know if you need me to show anything or if you need me to explain how to do this again.
You can make them nullable or not nullable. It's up to you.
And actually, yeah, it's probably a good idea to make them null.
Yeah, because if you make them nullable, that just means that you can enter a blank thing with it, or
yeah, you can.
So
leave
it really
them empty.
depends on what you're doing with it.
Usually, you make the primary key not null.
The primary key has to be not null.
Not sure why I need this, but I'm going to do that. No.
You're going to have to do a drop and replace.
Oh, I know why. I did. I left this one as a field ID.
Mm.
And I think if I change this to course ID, I'll probably break it.
You're going to have to do a table alter if you want to run it, or an alter table.
Let's see if it does it by itself. Nope, it doesn't.
It's going to break. If you change create to alter, it'll do it.
Yeah, it's not going to like it.
I don't know why.
At this stage, to just drop it.
Yeah, I mean, it's not like you're dropping any data.
Yeah.
It's not like people who go through and update an entire database without a where clause.
Oops.
Oh, in production, on a production database, on a demo, apparently. Yeah, it was all kinds of fun. Moral of the story, don't make your DBA want to kill you.
Paragraph 14, comment on. Also, we're meeting for service on Saturday at 9. I was thinking we could start service a little early since we work. We need to start putting in more time. I told we both had 3 hours. I had 3 hours for sure. I don't know where you got.
I had 3 hours.
Or how you got 3 hours.
I always get my hours.
Adam, you might want to mute yourself.
What would I lie about that?
How did you get 3 hours? We had an hour and a half. We went out early.
Let's see. Who do
And his sister and brother-in-law. We had an hour and a half.
There we go. Okay, close enough. Okay, so once you have that, you can close out these designers. They've served their purpose. And you can always go back and look at the table. If you open table definition, it'll regenerate all that if you need to make modifications. Oh, it looks like it put that in by itself. Okay, so does everyone have, looks like we're most of the way there. So I'm going to continue on. So now that we've got these, now we need to fill them with data. So I'm going to right-click on my table and click on Show Data, Show Table Data. And this allows you to put in some data. So just put in some information. So for campus, we'll put in the ones, I'm putting in the ones that we have here. You don't have to put all these on. You can also change your table links and stuff like that so you can see everything. Notice that the ID fields are being filled in automatically. And one thing with this is, if you're still in the, notice it's null right now. If you're still in the table row, it doesn't change. As soon as you change table rows, it will actually save it. So to make sure that it's updated, once you're done, click on another row so that you can make sure that your inputs are there. And then that means that your data is updated. So if I go back and open table, oh, I don't want the definition. Show table data, then I can see that it's there. Now at this point, now once you have data in your table, you want to be careful if you change the table definition. If you add columns, not a big deal. If you start subtracting things, you might be deleting some data, and then it gets a little more complex to update things. And usually that's the source of most of the fun involved with databases. And so just go through here and fill them all with, let's see, the course. I think I just did some. Make sure that your course ID is updated. That means it's saved. And then with major, again, show table data. And yes, so right-click on the table, Mary, and show table data. We'll open it up. And Tony, you get no row was updated. What might have happened is if I try to put a number in here, for example, if I put 4, no. Actually, it should just be able to type in your value. Physics, English. It should just update. You still having that problem with that, Tommy? That might be okay. You don't care if the ID field is contiguous. You might have deleted some elements, and it's fine if it's saying 11 at this point. What it will do is it'll prevent from having duplicate IDs. And basically what this means is that by always incrementing one, your ID fields will always be unique. Not only that, but if you delete a row and then, so for example, if I delete this row here, and then I add a new one, notice that it doesn't. It will never go back and make put 4 back in. Why is that a good thing? Because often you're going to be making relationships between these different tables, and they'll be you might have had some things pointing to 4 that may not be appropriate for 5. And so there's, when you take your SQL class, they'll talk about this thing called referential integrity, and they'll talk about other principles involved with databases. But basically, once you create a ID field for something, you never want to reuse the ID field, because what could happen is maybe you set some information and you have this orphan thing pointing to this ID field. You create the object, a new object, you give it an old ID field, and now it has this other thing associated with it which shouldn't be associated with it. So usually we don't care what the ID field is, we just want to make sure that it's unique. Okay, everyone with me? So now we've got a database, we've got some tables, we've got some data in the tables, and we're going to go and start working with the school class. So we're going to go open up school.cs, and right now this is a bunch of arrays. I don't like it being arrays because, well, we could deal with it, but I'm going to change all of these to lists. And so these will become lists of string. I probably should have started this starter with lists in here. At this point, doing this rewickering is probably painful. But and then we're going to make this one a list of students. And that means that then I also have to change all of these. So change this to all lists. And for me, I'm going to, just because in here I'm going to change this to all plurals. You can do this if you want. It just makes me feel better. I don't know what's the plural of campus? Campuses? Yeah, this should be a list of students. Ah, thank you. So change them all to lists, pluralize the names, and then and we're going to change this code here, so don't worry about this for now. Yeah. So, Ali, what you're going to have to do is make sure that once you change all these to a list of string, every property is changed to list of string. That I pluralized everything. So if you pluralize everything, make sure that everything's pluralized correctly, and you've got to go back and forth and make sure everything is referencing things correctly. So make sure all those names line up. And then down here, you're going to get red squiggles. That's fine because we're going to, in fact, I'm going to just delete this right now because we're going to put different code in here. And I'm going to type in the next method. I'm going to make a little helper method that's going to actually access my data. And then what this method is going to do is going to take a SQL string and I'm going to go over this in a second. We're going to need a connection string. Actually, I'm going to hold there. So I'm going to wait till everyone gets a chance to get up to that point. So let me know when you all are ready to continue. Okay, Eiley, let's see. So do a refresh on your tables up here and make sure that those tables don't already exist. They may already be there. So, and then right-click on your tables and see if you can, if they're already there, then just right-click on the table and show table data, and see if you already have your data in there. If you do, then you're probably okay. If you don't, you can probably if you have the right fields, ID and title, you can probably just type your data and you'll be okay. And you don't have to have specifically my data, just put some data in there. Cool. So update your data there, and then make these changes to the and the instructions are in the exercise instruction in the Word document. But just change your lists and do all that. Yes, you are. Did you want to show me where you're at? Yeah, don't worry about the design part. If you have your tables, Ali, just delete, close out that design table, and you're fine. As long as you have your tables already built, it should be good. No, not when you're adding data. So when you show, it says I type something in here. As soon as I move off of that, if I hit enter and I see the major ID, it's updated the data. No, I think that's probably just a residual from something that may have been typed in. If we need to fix it later, we can fix it later, but I think you're going to be okay. Okay, so when we want to, so once we have our database, the next thing we need is the connection string. An easy way of doing that is click on your database and go to properties. And conveniently, you're going to have right here connection and connection string. If you right click on that, if you double click on that, hit Control C for copy, and then you should just be able to paste that in. There's one problem, though. Can anyone see where the problem is if I just leave that connection string the way it is? There's red squiggles on it right now.
You have to add extra backslashes so that they're not read as escape characters.
Yeah, so it thinks that what we're trying to do here is do \D, just like you have \N or \T. So one way of doing that, as Carrie said, is you could escape out each of these slashes like that. I'm going to show you an easier way of doing that. You can just put an @ symbol in front here. That says read this string literally, and then you don't have that problem anymore.
Does
Can you get that connection string again?
Select your database, and then look in the properties for the database. It'll be under connection string.
Does the $sign also work?
I'm not
Instead of
sure.
an @ sign.
You give it a try. I've always used @.
Yeah, I usually do too, but I wasn't sure.
Is $sign used for format string? Is that one of the newer features?
I know it's a way to use curly braces. It doesn't. So, yeah. Because you can code in stuff with the $sign.
Yeah, I think that's for that new way of format. Usually, it's a new format string type of functionality that C# has. So that right now we're hard coding our connection string. We're going to learn. Yeah. So basically, select your database up here in your data connection, your Server Explorer, and then right here you're going to see in the properties for the database. You can just double click it, Control C, copy it, and then paste it in here, and it will put it in there.
I realized I was clicking on it in the Solution Explorer. I have to go to the Server Explorer and then do the properties.
Yes.
I wasn't getting that connection string.
And there's a Server Explorer, and then there's a SQL Server Explorer too, which is similar but different. Is that working for people? So right now we've hard-coded our connection string, and once we have that, we're going to make our using directive, and we're going to instantiate inside of our using directive a SQL connection. And it's probably going to give me an error because I need to add a using directive. So I'm going to hit Control dot on that, or right click and quick actions and refactorings, which you can see here is Control dot, and it'll tell me what using directive I need. So I'm going to do that, and it will add using system.data.SQL client namespace so that then it can find the SQL connection class. And I'm going to call it CONN, and it's just an instantiation statement, just like we've done with other classes. And the constructor for SQL connection, you can do one like that. You can also pass in your connection string and go ahead, and this is the one we're going to use so that it takes this connection string, and this connection now is the thing that's going to connect to this database in our program. So this is the connection. It's using this connection string to connect to this database, and we use the properties of that database has that connection string. So that's the thing that links these two together. Does that make sense?
Yep.
So we have a connection to our database now. And the next thing we need to do is we need a command. So using the same namespace, system data SQL client gives us also access to SQL command. And with SQL command, I'm just going to call it select command, or CMD, equals new SQL command. And a lot of times you can write it out here, but what I'm going to do is I'm going to just pass this into this function, because we've got three things that are going to have pretty similar SQL command. We're going to get our data the same way for all three of these. So I'm just doing this all with this one little helper function. So the SQL command is going to be the one that I'm going to pass in here later on. And then we also want to specify which connection we're going to use, which is this connection. So SQL command takes a connection, and so basically what a SQL command is it's going to take this string, which will have our SQL statement, and it's going to send it to this connection. So basically what you're saying is, hey, send this command to this connection. Now, it won't do that at this point. You've just created a command. It hasn't actually executed it. You've got to do, before you can execute the command, what you have to do is you have to open your connection, and then what we're going to do is we're going to actually execute this command. In this case, though, we're going to be passing in a select statement. So, for example, the way this is going to work is we're going to say get data, and then select star from campus from campus, for example. So this command will be sent into this parameter and will be sent to this SQL command, and this SQL command will then will be associated with this connection. We open the connection, and then we're going to, with our select command, you have actually several different execute functions. You have execute non-query, execute reader, execute non-query, and then execute query, or execute reader. So to explain that a little bit, I'm going to go back to my slides, and I'll come back to this. So to review the slides, we saw how, let's see, yeah, there's a SQL connection we created, and we made a connection, and we talked about how that connection is created. And we're going to demonstrate that using the connection string stuff in a little bit. And this is where we're building this structure here. We're opening up a connection, we're opening it, we're doing something, and then we're closing. And so basically what we're going to be doing is we're going to be saying SQL commands. That string that we're creating is the SQL command, and what your program is doing is sending it from your program to the SQL server. Often the SQL server in practice will be running on a separate machine. Ours is kind of running on the same machine for development purposes, but it's a program that's running that will take that command and then send back data. So it's sitting there waiting on a network connection, and then when anything sends it a command, it executes that command and sends back the data. So our command is a standard SQL command looks like something like this. Select, company name, contact name from customers. The command is just a string. We make a connection. We open the connection, and then we make this command that has the select statement or the query in SQL, and then the connection we want, and then and there's 3 different formats for this, or there's several different formats for these commands. The one we're going to be primarily using is this text approach, where we write our command, we make a command object, and we're going to talk about this parameters add with value in a little bit. And actually, I guess I'm going to talk about that later. So let's go back to where we were, because I think that's going to be beyond. So with this select command, we're going to execute a reader. And you use execute reader when it returns a value. And you're going to notice that execute reader returns back a result. And to be able to use that, what we do is create something called a SQL data reader. So in front of this, we're going to create a SQL data reader, DR, and we're going to, I wanted execute reader. And if you look at execute reader returns a SQL data reader as its output. It's 4.8. And the SQL data reader, what that is this an object? It's an object we can use to then pull the results out of our out of that query. So when we call this command select star from campus, it's going to get all the table data.
That probably should be from courses, because you're putting it into courses.
Well, the campus course is a major. Yeah, we can look at that one. We're going to be doing the same thing for all of them.
Line, yeah, but line 43 specifically.
Or did I mix them up?
Yep. Down, it was line 43 wherever we were at. School.c, yeah.
Yeah, that should be course. So this will read all those table elements we put in there, and then store them in this object called dr. So this dr will be a collection of rows, and to go through them, what you do is you use a while statement, and you say dr.read. Dr.read will the read command for a SQL data reader basically brings in one row at a time. And we're going to put each row into this list of items. And we're going to say items.add dr. And with dr, with this reader, you have a bunch of get commands. Get boolean, get byte, get chars, get datetime, get float, get int32. You have to know the structure of your data. So if I look at course, and I can actually expand this out, course has course ID and title. I don't want the ID field for my purposes here. So what I'm going to do is I'm going to get a string, and zero-based course ID will be 0, title is 1. So I want the first column, column 1, not column 0. I'm going to get column 1, and I'm going to add it to items. This will loop through and add to this list of strings everything that's in that database. And then at the end, once items is filled up, I'm going to return items. So to review, we get a SQL string that we want to execute on the database. We create a list of items, of strings, that we're going to hold this list of titles basically in. And then what we're going to do is we get our connection string, we connect to the data, make a connection to the database in a using directive so that when we exit it, it will automatically close. We create a select command, we open up our connection, we create a data reader, we execute reader on that command, and the reason we use execute reader rather than execute non-query is because the commands here are going to be selects and they're going to have things coming back. Once we have our reader, we loop through our reader to read each row. We use the get string command of the data reader to read the element we want. If we put 0, we would get course ID. If we said title, if we put 1, we get title. If you have multiple things to read in here, you would actually make a class to model that table, and then you would have a list of that class. We're keeping this a little simpler and only reading one field in for this first iteration of this. And then once we have our items filled, we return that from items, and then that gets placed into the list we want. And then we can use this to get our data for all three of these. And the commands will be select star, which means all fields from course. This one's from major, and this one is select star from select all from campus. Everyone got that? So once we have that, then we can, we have some other things to fix here. Because we changed things to lists, we need to change some other places. So it's because I have pluralized everything, I've got to change mine to the plural versions.
If you do control dot or control plus RR,
Yeah, then
all of them. Right.
Yep. And then I'm going to see if this works. And now I see that I'm getting each of these fields filled from the database. So, is that working for people? So let's take about a 10-minute break. We'll start back up at 7:25, and that gives everyone a chance to get caught up to this phase. The instructions are, we followed the instructions pretty directly on there. I may have changed some names of mine a little bit with some pluralization and stuff, but we'll take a break till 7:25 to let some of us catch up if we need to catch up. If you have any questions for me to clarify, let me know, and we'll try to get everything fixed and everyone up to speed to where we are.
Doesn't this class generally only go to 7:15?
Oh, you are correct. Let's say we'll hold there until next time.
Sorry.
Time flies when you're having fun. So thanks for letting me know. So we're going to stop there, and then next time we'll pick up with this and refine what we're doing a little bit. But that's our first introduction to working with data. I found working with data was a little complex to figure out initially. So we'll work through this and kind of get it sorted out and understand this pattern. But just to review, we create a connection string. We create a connection from that connection string. We create a command that uses that connection and a SQL command as a string. We open the connection. We execute the command. We get some stuff back from it if it has anything, if it's one that returns anything. If it's just sending commands to it, we'll actually execute a non-query, and it will just execute it, and then we're done. And then if we get stuff back, we do whatever we want with that data. So that's all I've got for today, and see you next time.
Right.
Let's see.